Oh, okay, which ones were resolved, and we decided that bromide ion, being in reduced form, which has a reduction potential less than that of oxygen, will be oxidized by the oxygen. And we don't have to concern ourselves with the overpotential in this case, because we're not talking about the water. It's the barrier for the oxygen interaction. And oxygen generally reacts, and the reason oxygen is so reactive, if you'll go back to chemistry 1A, recall it has 2 unpaired electrons. Okay?
Spinning the same way, right?
Well, that in one there are various possibilities. They can be parallel, which is the lowest energy. It's called triplet oxygen. And then you can have it somewhere where, they still be both unpaired, but in different orbitals. And that would be a singlet oxygen, which is very reactive. They're both reactive because they have unpaired electrons. This is called a radical, a free radical. Any unpaired electron has a very, very low activation barrier. So oxygen really has a low barrier. That's why it's so reactive, because it has 2 unpaired electrons. So that goes back to 1A. And you have to understand the molecular orbital approach for that. Okay. So yeah, but it goes to why don't we have that huge overpotential requirement? And that's why, because oxygen is diradical. Now, so the only one I see in there was the reduced form is bromide, so that answers C. Now, so C is bromide. Now we're going on to D, which is hydrogen will be produced at the cathode